Problems with longevity, heat production, and availability of batteries are related to today's battery technologies. Satellites, medical devices, spacecraft, and high-altitude drones all require extremely long-lasting energy storage, but lithium-ion batteries cannot meet all of these requirements. Some companies, however, think their diamond battery technology can do two things at once. One, provide a kind of energy storage that can last for thousands of years, and two, put nuclear waste to use in a way that could possibly power everything from electric vehicles to cell phones. Is this really the end game for battery research? Or just more advertising? Can we be sure that we'll be safe? Let's take a closer look at the potential of nano-diamond batteries. A lithium-ion battery is likely powering the device on which you're viewing this video. If you drive an EV, you may thank lithium-ion batteries for it. Nowadays, batteries are used for everything, from communication to transportation to storing energy generated from renewable resources like solar and wind, and so on. And there's no denying that advancements like lithium-ion batteries have made a huge difference in our current modern world. Lithium technology, it still faces obstacles like overheating, short lifespans, or poor performance in severe environments. And in order to achieve carbon neutrality in the coming decades, we'll need both batteries and renewable power sources to advance and evolve. And that's exactly what scientists are working on. As a result, we now have the diamond battery, which has the potential to radically revolutionize our society. One of the companies involved in diamond battery technology is NDB, a startup based in California, and they announced their new nano diamond battery. Other people call it the nuclear diamond battery because the technology behind NDB is encapsulated in artificial diamonds created from nuclear waste. The root of this energy storage technology is known as beta voltaics. The use of semiconductor materials to convert beta decay energy into electricity was first proposed by Paul Rappaport in 1953. He revealed that when positioned near a radioactive source, beta voltaic devices can generate current, unlike conventional energy generation methods such as hydro or wind turbines, which spin copper coils within magnets to produce an electric current. Just picture putting some strontium-90, a radioisotope created by nuclear fission, in a box with a semiconductor material like silicon. Almost 30 years is its expected lifespan. It's actually very similar to how solar cell works when collecting solar radiation. In this case, the radioactive element emits beta particles that separate electrons and hole pairs in the semiconductor. The holes collect on the positive side, and electrons collect on the negative side. Connecting the two sides allows the electrons in the holes to find each other, resulting in an electric current. In short, it turns radiation into electricity using this principle. Using this beta voltaic principle, scientists at the University of Bristol announced the world's first diamond nuclear battery in 2016. In a lecture, Professor Tom Scott explained that his team had grown the synthetic diamond that can generate a small electric current when placed in a radioactive field, and according to him, one of the benefits is a long-term emissions-free production of clean energy from nuclear waste. A great portion of nuclear waste is graphite. Graphite is used as a moderator and reflector in a nuclear reactor, and it becomes radioactive over time because of its exposure to radiation. Graphite is important because, in radioactive graphite, carbon-14 decays into nitrogen-14, and an antineutrino, in the form of an energetic electron, also known as a beta decay electron. The goal of the research at the University of Bristol is to make batteries that can use carbon-14 byproduct, graphite, as a source of energy. In its gas form, it can be turned into a radioactive diamond by putting it under low pressure and heating it up. Then, for safety, they wrap it again in a layer of diamond that is not radioactive. So basically, it's a radioactive diamond inside a diamond. Generally speaking, when we think of nuclear power, we think of a lot of energy being made, but the most power these beta voltaic batteries can produce is in the microwatt range. This is why headlines and press releases about NDB batteries have been overselling it. I personally don't think this is the future of electric cars. Aside from these safety claims, the company says that its technology has a maximum lifespan of 28,000 years and could one day provide low-carbon power for TVs, smartphones, and anything else that needs it. Even though this technology looks great, it's still a big question mark because the power it gives off is so small. Remember, it's measured in microwatts. Where does it make the most sense for these technologies to be used? And would people buy it? Well, the company hopes to start selling the battery to commercial partners, including space agencies for long-duration missions by 2023. However, NDB is not the only company in the nuclear diamond battery game. Scientists at Bristol saw a big opportunity in attracting and reusing nuclear waste, so they started a company called 𝐴RC to make their diamond battery idea a reality. Compared to NBD, 𝐴RC approach is a bit more realistic. The company sees its batteries powering small detectors, wireless IoT devices, sensors, or medical implants. Researchers at Bristol University and NDB say their nuclear batteries have low or no radioactivity because of the diamond isolation. Putting aside the overhyped news, diamond batteries still hold some interesting promise, but they are still in the theoretical phase at the moment, so we will have to wait for a few more years till NDB and 𝐴RC have real prototypes and factual findings before making a final judgment. However, not every battery innovation has to be a direct competitor to lithium-ion. Now that we've put away the inflated publicity, what are your thoughts? How about you? Do you see any potential here? If you enjoy this video, please share your thoughts and also support my baby channel by pressing the subscribe button and hitting the like too. See you next time.